Welcome to Base Space, a crypto podcast. Base Space.
Hey everyone, welcome to the Base Space. This is a crypto podcast hosted by myself, the Crypto Mewtwo, with Chase Coins and Super High, and we focus on creating opportunities for growth, networking, and education in the crypto industry. Today we have the honor of having Erick, founder and CEO for Cartesi. Welcome to the show, Erick. We're pumped to have you on, man.
Thank you, Mewtwo. Thanks, everyone. It's a pleasure to be here.
Absolutely. It's a little bit of a tradition here at the Base Space. Whenever we bring someone on, we always love to hear like their crypto story, maybe keep it brief and just tell us how you got into the space.
Sure. So back in 2016, I was a digital nomad as well. And I was working for the software industry for several years, like almost 20 years. And developing for Web 2, desktop, different industries. And then in 2016, I started to get to know about Bitcoin, about Ethereum, and I got caught, right? I thought it was quite interesting, revolutionary. And back then, I was just playing with small amounts, investing a little bit of money here and there, just to understand and play with platforms. And started to develop some software to help me to get data from exchanges and analyze data to know how to put the money. And that started to hook me in. And I was traveling the world back then. I was living in Asia, and I was also at a point in my life that I wanted to make a change because I was kind of exhausted about doing the kind of software I was doing before. So I was an independent developer, but in the end, I was working like an agency. I had a few people from around the globe that were working for some software projects that I was leading. And around that time, a friend of mine that went to school with me, he called me from his math institute in Brazil. He said, look, I'm developing with my colleague here at IMPA, this Institute for Applied Math, Pure and Applied Math in Rio. And, we are academics. We want to make this project a real business. Would you like to be our CEO? I say, yeah, why not? I was at a point in my life that I was really into crypto and into blockchain. I was fascinated about what they were trying to build. And got some good people around me that I knew from the entrepreneurial space here in Taiwan, and we founded the company. It was not an easy beginning because right after we decided to start, we incorporated in early 2018, the crypto market started to go down. So Cartesi was born really in the crypto winter.
That's amazing. Yeah, how did you survive? Like, what was it like building in a bear market? And are there any key lessons that you took away from that maybe other founders should be aware of now that we're kind of entering a similar bearish period?
Sure. I think there were a few factors that were very important for us to persist. First of all, we had a group of people that knew each other for some time. One of my best friends was one of the co-founders, and we also got the support from Sergey Popov, one of the founders of IOTA. He was the first person to invest, to put some money in Cartesi. Basically because he was a colleague of Augusto, another co-founder who is a math professor. Augusto and Sergey Popov co-authored a few technical articles in math. So they were colleagues, and Sergey, before we started Cartesi, Sergey was poking Augusto to get into crypto, right? And Augusto read the Bitcoin white paper, got very excited, and that's how things start. So we started with some money, not much, and I kept my my daytime job, my previous projects. I was working part time at the beginning. Most of us were working part time at the beginning, and after that, we entered we went through China Accelerator, which is a program uh, that is capped by SOSV, one VC funds in the US. They have these accelerators around the globe. And then they decided to invest, put some money into our projects. In 2018, we spent one month, 3 months in Shanghai going through their program, which was also very interesting and valid. And then we kept trying to fundraise for several months, talked to so many investors, but the whole atmosphere was quite pessimistic back then. But we were passionate about what we were doing. Although, to be frank, at the beginning, there were more questions and more unknowns about the direction to go and the business models. But we had a lot of passion to keep going.
Yeah, that's amazing. And I think you mentioned like your team is 50 people, right?
Correct. Yeah. And then eventually we went to we fundraised through a couple of private rounds, got some investors, and eventually we went to Binance Launchpad 2020. And I think that turned things around. Was a major event. When we went to Binance Launchpad, we were also wrapping up the development of Crypts, which was a game that showcased the potential of our platform. What we're trying to prove was that it was possible to run a complex computational thingy, run a heavy computation in a decentralized way, preserving the security guarantees of Ethereum. And we developed a tower defense game. We went with that game through Binance Launchpad. People loved it. It was super interesting, very euphoric time. But then we had a lot of work from that point on.
I think that's really important. You touched on just everyone kind of have a common goal while in the bear market, because you can't just always be incentivized by money, right? I mean, you have to be wanting to build something. So I think that's really great. Just for the listeners that are listening on Spotify or here now, could you give a high level explanation of what Cartesi is and what you guys do?
Sure. So I think everyone here, or probably everyone, is familiar with the idea of layer 2 technologies, the scalability issues of blockchains. So most of the projects that are working on layer 2, like rollups, ZK rollups, optimistic rollups, they are trying to increase the computational capabilities, the number of transactions people can do per block, and diminish costs, etc. But they are trying to preserve the programmability that we find today on blockchain. So they are EVM compatible. Usually people develop things for layer 2 using Solidity, or they just port smart contracts that were running on layer 1 to layer 2. The basic idea is for people to get more scalability, right? That's the main reason for people to develop these layer 2 systems. In our case, from the beginning, we realized that there was some interesting opportunity here, because because the computational abilities of blockchains are so low, then people had to develop these minimalistic virtual machines and environments that are very simplistic. You cannot run heavy systems. You cannot boot an operating system or things like this, because your computational ability is really low. You have a low amount of computation that fits in a block, and so on and so forth, right? So our idea was to start to use these principles of scalability, first of all, we thought that, okay, so if you can move away from global consensus that blockchains do and go toward a local consensus where only the interested parties, people who are interested in the result of the computation, are really verifying, then we can really scale things up to a point that we can run a real operating system, right? So we started to push these boundaries. We understood that by having a layer 2 like this, we were able to offer to people a programming model, a computational environment that's similar to what people are used to on mainstream, right? One of the barriers today for people to enter blockchains is that they have to learn new concepts, they have to learn new languages, they have to get used to new development tools, and they are rather limited if you compare them to what people have on mainstream. So that's the overall idea of Cartesi. We are actually bringing to the blockchain space for the first time an actual operating system. So instead of developing smart contracts using Solidity, you can actually bring your old traditional way of developing using mainstream software stacks, components, libraries. You can run a database, you can access the file system, you can do things that people normally do when they develop for Web2, for instance.
That's great. And so I know you just mentioned, now you're not just limited to Solidity or Rust. What has been like the biggest challenge for implementing this approach? Allowing people to use C++ or Python or other programming languages.
Well, I think that the basic thing here that we're implementing that's puts us apart compared to other projects is our virtual machine. So a big part of our efforts, if not most of our efforts, are around pulling off this virtual machine, which is not EVM compatible, it's not EVM based. It is a virtual machine that's based on the RISC-V instruction set, which is an instruction set use a computer architecture for a real hardware, right? And it's an open standard and so on, and it's possible to run operating systems like Linux on top of this architecture. So the biggest innovation here is our virtual machine. It's not really, it's challenging, but it's just a lot of work. Everything that we have had to do for this machine have been doing significant steps forward. It's very mature today. There are a few optimizations that still have to do, but throughout these 4 years, we have advanced a lot with this piece. Now, when we want to provide people a model that's similar to smart contracts, similar to what other layer 2 are doing, meaning that you can enter with your funds on layer 2, then people can interact with smart contracts on layer 2. Eventually, they want to exit. They want to go back to layer 1, but they just interact with the systems for a long time on the layer 2. So for us to enable that part, we also had to implement something like other projects are doing. In our case, we decided to implement optimistic rollups with interactive dispute resolution, which is similar to what other projects are doing, like Arbitrum. But yeah, we have everything mapped. The great innovation is really the virtual machine. But when we bring those two pieces together, the virtual machine and optimistic rollups, you can actually then have a second layer where you can run an operating system.
That's awesome. So that kind of like spawns two questions for me. So the first one would be, are you guys multi-chain compatible? And then the second one would be, how do Cartesi rollups differ from other traditional rollups, maybe like ZK rollups? I know you guys said you're an optimistic-based rollup, but just for the crowd listening that may not know.
Sure. So in the case of ZK rollups, the systems operate under the basis of validity proofs, meaning that whenever you want to realize something that happened on layer 2 back to layer 1, through ZK rollups, the system will present the results to layer 1 with a cryptographic proof that that result is valid. So layer 1 can just verify that proof and immediately accept the results and finalize the transaction on layer 1. Now, with optimistic rollups, it's a different principle. Instead of using validity proofs, you use fraud proofs. So people just assume that whatever a validator on layer 2 is telling to layer 1 is accurate, is correct, is valid. And there is a challenge period in which other validators can verify if that result is correct or not. And if any other validator during that period realizes there is a fraud, then they are able to initiate a fraud proof through layer 1, right? So that's the main difference between optimistic rollups and ZK rollups. Then, when you go down into optimistic rollups, there are two subdivisions here as well. So we can, for instance, compare what optimism does to what Arbitrum does. So in the case of optimism, whenever a validator comes back to layer 1 saying, oh, this other validator is not acting honestly, I want to start a dispute, then basically what the layer 1 has to do is to repeat the entire computation that happens on layer 2 on layer 1. Because then when you run the entire computation on layer 1, then there is no more doubt left. So whatever layer 1 says is correct, and end of talk. But then that has implications, right? Because you are then limited by the amount of computation that would fit in a block, that would fit on layer 1, that would be affordable on layer 1. So there is an important computational limits when you are dealing with this kind of rollups approach. Now, what Arbitrum does and what interactive dispute solutions allow us to do is to expand the limits of computation far beyond what the blockchain can actually do. So, and that's the same algorithm that we are implementing at Cartesi. So basically, when one validator says that another validator is sending something that's incorrect, instead of running the entire computation on layer 1, which would be infeasible, then they start a game in which the blockchain makes questions to the two validators, trying to spot the points in which the point of the computation in which they are in disagreements. So the bulk of the computation happens off-chain, even in the case of disputes, and you only have to run a very small piece of the computation on layer 1 to find out who is right and who is wrong. Then, by using this kind of optimistic rollups with interactive dispute resolution, since we can now scale computation to the orders of magnitude of, let's say, tens of thousands more computation than what you'll be able to do on layer 1, then you can start to think about using more traditional computational models and environments. You can actually start to run an operating system. That's exactly what you're doing. When you have this level of computational scalability, you can now start to think about traditional computational ways of doing things.
That was a lot. Oh, go ahead, just.
Yeah, I was just going to hop in. I was going to say, hey, Eric, sorry if you had maybe addressed this already. I've had some connections issues. But, a lot of developers, like a core pillar and a core tenet for them is decentralization. And so I just wanted to see if you could touch on how the Cartesi machine is decentralized.
Sure. So the Cartesi machine is the VM that we are going to use for Cartesi rollups, which is the system that I just explained using this interactive dispute resolution method. The way that you decentralize is by having a set of validator nodes that will run the Cartesi machine off-chain, right? So when people want to interact with applications running on layer 2 on Cartesi, they have to lock their funds on layer 1. Now their funds appear on layer 2, and users start to interact with the app on layer 2. That's exactly the same concepts that you have on other systems like Optimism and Arbitrum, or even ZK Sync. Then you are not, from that point on, who is running the computation is not the blockchain anymore, right? So whenever a user sends an input to a smart contract or input to the app running on Cartesi, the validator nodes of chain are the ones that are advancing the states of the application, and just performing everything it needs to perform on layer 2. Excuse me. Then, so what's going on here is that you are moving away from layer 1 into layer 2, all the computational loads and the advancement of the state of these state machines. So it's the validators on layer 2 who are performing the work, right? And that's the same thing that happens on other rollup solutions, not only in Cartesi. So this way of doing things is not particular to Cartesi, it is particular to rollups.
Gotcha. And so the Cartesi token, what role does that play in the ecosystem?
That's a good question. So the Cartesi token will have an importance in the decentralization of Cartesi rollups itself, right? So you can think that when you're running your app on Cartesi, you have a set of validator nodes validating the computation. Whenever they disagree, they can enroll, they can go through a dispute resolution method mediated by layer 1, as I said before. There are a number of services that are necessary for Cartesi rollups to work. So for instance, whenever you want to go back from layer 2 to layer 1, there is the concept of a voucher, which is data that needs to be bridged back from layer 2 to layer 1. And whenever you have to run this voucher on layer 1, there is a question of who should be running this voucher. There must be some economic incentive for people to just execute this instruction back on layer 1. And that's one example of where CTSI token enters, because currently you have a proof of stake system that has been online for quite a long time now, stable, that is able to select nodes based on how much people are staking, right? So by using the proof of stake system, certain nodes are selected randomly. And for instance, they can be the ones selected to run the voucher that I just explained back on layer 1. Another thing that's another role that CTSI will play for rollups is in the aggregation service. Another very important aspect of rollup solution is the need for you to have what they call sequencers or aggregators. Basically, what they do is to gather lots of input from people, from users, compress these inputs, and then insert on layer 1. Right? So the aggregator is this system that's responsible for compressing inputs from users and putting on layer 1. And again, who is supposed to perform this service? Usually, in current rollup solutions, you have aggregator systems that are somewhat centralized. In Cartesi, we are working to develop a really decentralized aggregator service And again, CTSI would have a role to play here in the sense that the certain nodes would be selected based on their stake to be the aggregator for some time, right? Then there will be also liquidity provider services. And again, the same concept will apply, that certain nodes will be selected, certain parties will be selected based on their stake to provide the service to Cartesi rollups. So CTSI will be really a very important piece in the decentralization of our layer 2 system. There is another piece that we are developing, which is a long-term project, which is a data availability ledger. So right now, if you want to use Cartesi rollups, you have to put all your data on layer 1. And of course, you'll be again limited by what's reasonable for you to put on layer 1 in terms of data, because it can get very expensive to put data on layer 1. And that's a problem that's shared by any rollup solution. Any rollup solution needs to put data on layer 1. Even if it's compressed, you're going to reach to some point that things start to get very expensive. So another way of doing things is for you to use other data availability solutions. That could be in the form of side chains. People talk about Validium and other kind of solutions in which data, instead of going back to layer 1, goes to another layer that is less safe than layer 1, but it's still acceptable for a broad range of applications. Another project of Cartesi is to develop a side chain that will be a data availability layer. We call this project Nother. And that will be a side chain where people can store more data than they would be able to store on layer 1. And then CTSI will play a role there as a crypto fuel, similar to what you have on Ethereum, right? People need to spend ETH to send transactions to blocks on Ethereum. In the same way, people would need to spend CTSI to send data to Nother in the case of Cartesi. So all in all, we are working to give broad utility to CTSI. It's going to have an important role to play in rollups. It's going to have an important role to play in the sidechain Nother as well.
Gotcha. Yeah, thank you for diving into that. Now, I want to unpack a few things there. I guess my first question, you had kind of touched on this a little bit on the proof of stake. How is it determined what node would kind of like lead the validation? You had talked about it was random, but how is that randomness determined? And then the other question is there a minimum stake allocation that you need to have, or can anyone kind of be involved in that process?
Yeah, it's a good question. So the way that we calculate that we generate randomness is based on the block hash of Ethereum itself. So you can assume that the hash of a block on Ethereum is pretty much random, and that is used as a seed for a probabilistic function that will somehow elect nodes to receive their reward and to be performing such services that I explained before, right? So basically, it's a math function that throughout time it's kind of allows more and more nodes. Each node has a kind of a seed or kind of a cryptographic signature, and throughout time you have more and more nodes through their random signatures getting more and more likely to be selected. So it expands gradually, and eventually throughout time one node is typically selected before the others. So this node is able to go to the blockchain and say, hey, I got now the right to create a block and to receive a reward. And then the blockchain verifies through the mathematical probabilistic function and checks, okay, yeah, this node really passes the test. and it can be rewarded. So right now, what our proof of stake system is doing is running this stochastic probabilistic system. The more stake you have on a nodes, the greater the probability of this node being selected. That's also a very important feature in the system. Otherwise, it wouldn't be a proof of stake system at all. So in the mathematical function that I just explained, the more CTSI you stake on a nodes, the more likely it is for that node to be selected first before the others. Now, there is no minimum stake of CTSI for people to run their nodes. But one thing to consider here that's very important is whenever you're running a proof of stake node for Cartesi and you are selected, you have to go to layer 1 and claim your reward in CTSI. And running that function on layer 1 costs gas in ETH. And you can have a kind of a wide variation on the price of this claim, depending on the gas price. So if it's important for you to have enough CTSI stake in the system, right? So one thing that we did recently that was very important was a delegation for proof of stake that allows now for people to stake their CTSI without having to run their own nodes. So from some time on now, people can just take their CTSI and delegate them through a smart contract to a node operator, and everything is done in a non-custodial way. I mean, everything is secured by smart contracts. People don't have to trust the node itself. And of course, the more CTSI you have on the node, the more likely that node is to generate the next block and be rewarded. And when the reward comes for the nodes, it splits proportionally among the CTSI holders that put their CTSI on that node. So that's basically how it works. Yeah, the system has been on for quite a while now, and it's very stable.
Gotcha. I kind of want to shift gears here for a second and talk about just partnerships generally and like kind of the ecosystem, what you're seeing in some of the dApps being created. But I believe you guys are a partner with Chainlink. Could you kind of touch on that partnership and how you're utilizing Chainlink?
Well, we have so from the one question that I forgot to answer probably here is, I think you guys asked before if Cartesi intended to be portable across different chains, and the answer is yes. From the beginning of the project, we knew that we didn't know if the future would be multi-chain or single chain, and we have been developing things in a way to make sure that Cartesi will succeed no matter how the ecosystem develops. So we want to run on top of the most important blockchains like Ethereum and many others. We had very important good talks with several projects in the past, like Avalanche, Elrond, and others. And we have been preparing to integrate with these projects. Of course, we have to start by focusing on something, right? So our MVP will first be deployed on Polygon, also for the sake of reduction of fees and being more efficient. But the long game of Cartesi is to, for sure, run on top of Ethereum and any other chain that is, relevant and important, has a good user traction. And we have been talking to several different parties in the industry, including Chainlink, keeping an eye on everything that's going on. So at some point, after Cartesi rollups goes to mainnet, it will be important to integrate oracles directly to the rollups layer and things like this. So that's why this kind of partnerships and agreements are important for us.
Very cool. And to Chase's, I guess maybe Chase was his first point was asking like what kind of dApps are currently built on Cartesi. Would you share like some of the protocols that are currently using the platform?
Yeah. So right now we are not on mainnet yet, right? So we are working to get to the first version of Cartesi rollups soon. I actually have a lot of focus and effort being done in that direction right now by the tech team. But throughout the time, we have Cartesi itself has developed a few applications to showcase the platform, show the potential of what we're building. So the first thing that we developed back in 2019, 2020 was scripts that I mentioned at the beginning of our talk, which is a tower defense game, showing that it would be impossible for anyone to run a simple game, even if it's a tower defense game on a blockchain like Ethereum, because the amount of computation is orders of magnitudes beyond what's possible for you to run on chain. So we developed scripts to prove that concept. More recently, we developed Texas Hold'em. We're playing with the words here because Texas Hold'em game, but we just play with words instead, called it Texas Hold'em. It was used to prove that not only you can run more complex computation on Cartesi, but you can also leverage privacy features. So in the case of poker, you have to maintain privacy. Players have to conceal the cards. And of course, if you want to do something like this on chain, you also run into a problem because everything is there on the open for everyone to see. So using Cartesi, you can also use zero knowledge system to develop something like a card game like poker. So we actually created a game, a heads-up poker that's fully decentralized. And everything runs through the parties, the players that are playing outside, and the validators, and you don't have to trust anyone. Don't have to trust the players, don't have to trust the validators. If there is someone trying to cheat, the blockchain can be used as a mediator to prove whoever is right is correct. And more recently, we are also working with a few software agencies and integrators who are developing several demo applications on Cartesi rollups, right? So we have people playing around with computer vision software compiled to Cartesi. We have people playing around developing a battleship game and many other things. So there are lots of projects that are going on right now with close partners of Cartesi, which is very important for us. For when we launch Cartesi on mainnet, we have actual products, actual demos for us, or for people to get inspired, for developers to get inspired, to know what they can do with our tech. Our focus now is to give a lot of attention to education, to showing with examples what people can do with our tech, right? Because you have to consider that what we're doing is very potent, because we're bringing for the first time a real operating system to people to develop. Not only people will be able to develop much more sophisticated smart contracts and applications, but also that opens the door to mainstream developers to enter blockchain much more easily, because they can come with the tools, their languages, the stacks they're used to develop their Web3 applications. So it's very important for us to show to the world of developers what they can do when Cartesi is ready on mainnet. And that's our focus now.
That's awesome. And have you guys announced when mainnet is supposed to be live, or do you have an estimated timeline for that?
We are trying to. We don't have a specific date for mainnet. what we're doing recently is to try to be very clear about every single step we do toward mainnet. So every month we have a technical report in which we show the progress. We have new releases coming every month, and we are doing very fast progress toward mainnet. So I think around July, August, we're going to have a very complete version on testnet. Things are getting pretty much mature at this point. Anyone can go to our Medium blog and see these technical reports in detail. The tech team is also always available to talk and discuss our progress. And after we are on testnet, it's just a matter of stabilizing, doing auditing, testing enough, and feeling safe to move on to mainnet.
Very cool. Yeah, I look forward to seeing that and seeing what type of dApps are built on top of Cartesi. So I'm pumped for you guys to go live when you're ready. I also want to talk to you about Cartesi Labs. I saw that you guys had like a grant program and so forth. I was wondering if you could talk about that and for any of the listeners that want to get involved in that, how could they apply?
Sure. So Cartesi Labs is a funding program that we created, through the Cartesi Foundation. The idea is to have funds allocated for the community of developers to come up with applications to develop the ecosystem further. So we have grants, and together with these grants, we're developing a number of educational contents and ways for people to get engaged, to get to know more about Cartesi, to try the technology. But essentially, Cartesi Labs has the mandate to provide funds to foster these applications on Cartesi. So these funds will be distributed through different ways, right? So eventually we can run hackathons on systems like Gitcoin, as we did in the past, by the way, and through other means.
Very cool. And I believe you could just go to the Cartesi website, guys, to apply for that, right?
Exactly. So if you go to the Cartesi website, you go to Labs, you see a step-by-step guide for you guys to just apply. You have to fill in a form to send us your proposal, and then we can evaluate.
Awesome. Eric, at the end of these convos, we sometimes allow like guests to come on and ask questions. Are you down for that?
Of course.
Hey, let's do it. Guys, if you have any questions in the audience, just hit that request button. We'll let you guys up one at a time. But in the meantime, Eric, just really appreciate you taking the time out to come and talk to us and educate us on Cartesi. I think it's a pretty cool project. I love how you're bridging the Web 2 world, right, with Web 3 and making it easier for developers to come on board, because that's definitely like the biggest barrier or one of the biggest barriers that we see is, hey, you have to learn this other programming language that could be very confusing, like Solidity or Rust.
Yeah. And not only that, right? I feel that Web3 is still in the early days somehow, and there is so much for us to discover in terms of possibilities of what we can do with Web3. And I think we have much greater, as an industry, as a community, we have much greater aspirations of what we want to do with all this tech, right? So I think we want to go beyond simple DeFi, simple games, and the things that we see nowadays. We want to see things that are much more complex and interesting, that will bring users to Web3, not only because they want to invest their money and have gains, which is totally fine, but actually people will start to engage with Web3 because the system also brings other value to them, like Web2 does. Like, people engage in Web2 because they want to socialize, they want to share information, they want to buy and sell services and goods right? Or for entertainment. There are several reasons why people engage in Web2 nowadays, and we really haven't seen that happening to Web3 yet. Right? I think most of the crowd that is in Web3 is coming due to DeFi, play to earn games, and now we also have NFTs, which is a very interesting emergent phenomenon in the space. But I hope that we're gonna see in the future, in the next years, as we have technologies like Cartesi, as we have better user experience, that you're going to see the emergence of very interesting systems that will bring this new audience, these new users to Web3 as well. And that's what I'm working for.
Yeah, 100%. Yeah, the whole NFT thing kind of caught me off guard. Wasn't expecting that to blow up this past year, but it's been wild to watch. That's for sure.
Yeah. But yeah, if anyone has any question, please raise your hands.
We'll give it another second or two. If
yeah,
not,
I think we
no
did
worries.
have someone that was one to ask the question earlier, but I think it was way earlier in the episode, but I don't think they're here anymore.
Yeah, Eric, just thank you again for taking time out of your day to come on and, inform us about Cartesi and, just help educate users.
It's my pleasure. Thank you all for having me on the show, and thank you everyone who came here, spending this time here, learning about Cartesi. And we love to talk to people. If you guys go to Telegram, there will be people there to assist you. If you guys want to learn more about the tech, or if you want to start to develop something with Cartesi, I recommend you guys to go to Discord. We have developers there, technical people who are eager to help, to give instructions on how to start with Cartesi. And yes, please feel free to spread the word. We are very excited with what we're building, and your support is very important for us.
Right on. Thank you so much, Eric, for coming on. It's been based. I hope everyone has a good night, a good morning, wherever you're at, and we'll see you guys next time. Thanks again, Eric.
See you guys. Thank you.
Thanks, Eric.
Bye.
Based space.